In the preceding examples, we've looked at introducing some of our basic derivative properties, but only looked at functions with a single term. We know that functions can have more than one term, values added and subtracted from each other. So we need a derivative property for tackling those. And our sum and difference rule is going to tell us that in order to take a function f of x, either plus or minus g of x, and differentiate it, we do that by just differentiating term by term. Meaning we'll find the derivative of the first term plus or minus the derivative of the second term. And we apply those properties that we've already established as we proceed through each term. So in example 11, to find r prime of x, we'll take the derivative of negative 4x to the fifth minus the derivative of x minus the derivative of 6, which will give us negative 20 x to the fourth minus 1, and we'll put minus 0 in there as a placeholder just to see what happened to that term, but essentially just disappears because we don't need to write out minus 0. So our final answer here for that derivative function would be negative 20 x to the fourth minus 1. To find m prime of x, or let's stick with that notation, dm over dx, we would again differentiate term by term. The derivative of x to the negative fourth would be negative 4 x to the negative fifth. The derivative of 2 e to the x would just be 2 e to the x. And then as a placeholder again, we'll just indicate that we get minus 0 for the derivative of that constant term, meaning our derivative function is negative 4 x to the negative fifth plus 2 e to the x. In example 13, we want to find dg over dx. And we'll proceed in the same fashion. We'll differentiate term by term, which will give us 10x minus 5 times 1 over x plus 0, or 10x minus 5 over x.